Right, well, good evening, everyone. It's a great honor to inaugurate anything, and particularly something in the area of space engineering. I started off my academic career as a mathematician, then became a physicist, and then very late in my career I realized it was really all up to the engineers, because the engineers get it done. And I'm extremely proud to lead a very large number of engineers in ESA, and via that in industry, building very exciting things. But it's very nice to be chosen, a physicist by training, to be chosen to inaugurate something in engineering. If I was starting over again, maybe I'd start somewhere like this, but there you go. Now, I'm promised that this will get rid of that. Let's see. Ah, yes, it does. Good. Okay, well, because I'm not really an engineer, really a physicist, and even a mathematician in the past, you'll find really I'm a philosopher. And I want you to think, because really I think thinking is about what this new laboratory is about. And I want to think about space. I want to tell you some of the reasons that I have absolutely no shame in the size of my budget. In fact, I think it should be twice as big. Absolutely no shame. And it's not because I'm a terrific egotist. Well, maybe, but I mean, that's not the reason. The reason is because I think this is very much at the heart of a modern society. And I think that is something that's not always understood in this particular country. And I'm not talking about Scotland, I mean the whole of the United Kingdom. Somehow we don't actually realize how much it's important to think about the future and how much it's important to think sideways, out of the box, and push back frontiers without exactly knowing where you're going. And that's pretty amazing in a country that once did much of the exploration of the world, or at least the piracy after the explorers had been. You see, I work in a European space agency, and I have a European perspective on the exploration of the Earth, and the Chinese would probably say something different. But anyhow, I work at the European Space Agency. It's a full-service space agency. That is, we do everything from having astronauts, although now one British astronaut, I'm proud to say. He's not in that picture, I'm afraid. We build rockets, Ariane, now two more we're responsible for, one in cooperation with the Russians, Soyuz, and the other is Vega. So we will have a family of rockets. And unlike other space agencies, you may have heard of the American Space Agency, NASA. Unlike NASA, we are responsible for building things that really do provide applications in our society today. In America, there are agencies that do that, but they're not called NASA. They're called the US Air Force, or they're called whatever. Maybe I don't know the names, but okay, so I work for ESA, and you probably know what ESA stands for. Science, of course, is for S, the central issue. I drew up this slide when I was Director of Science, so you may see a prejudice there. The A is applications, which is the bit that NASA doesn't have and we do, and it changes the nature of our agency, very importantly, and in fact I think improves it. And then the E is exploration, because thinking of space purely from the point of view of applications misses part of the point. Space is very expensive. Once you've got off this planet, which you need rockets for, which is something not understood in this country, but simple principle of defeating gravity requires rockets. Once you've got off the planet, there are myriad things you can do. And the expensive bit is often getting the infrastructure to get off the planet, or things associated with the fact you've got to do things off the planet. You develop engineering techniques that have to work without the capacity to go up and kick it if it doesn't work. Well, we do kick it, but not with our feet. I mean, we kick it by changing the level of heat on panels and things like this. I was amazed when I became director how much kicking goes on, but that's probably something I should pass over. So what is the relationship between the things illustrated on the last slide and labeled here, man in space, space science, and there by space science I'm meaning looking out beyond the Earth, looking away from the Earth, looking at the neighboring planets, but also looking beyond into the galaxy, indeed back to the Big Bang. This year we launched 2 spacecraft, I'll tell you a little about them, which one of them takes us right back to the Big Bang. So we, in space, allows us to go literally to the final frontier, because I have to tell you the Big Bang is the final frontier, at least as far as physicists know, or physicists could even talk about. So we really do have the capacity. How are all these things linked, apart from the fact you need rockets? Well, they're linked also by the engineering techniques you need to undertake them, and in particular the links to things like Earth observation and navigation are very much tied together with advances in space science. And the 2 things, the 3 things are linked, and one feeds off the other. It's very important to understand that, and if you like, you need creative engineering to pull this together. Okay, so what is space exploration? I think some of us thought this was it. Landing people on the moon. This was done 40 years ago. And frankly, there is somebody, at least one person in the moon who worked on the Apollo project. I can see sitting in the back row there. And indeed, I worked on it very indirectly because I worked for the BBC on the coverage of the Apollo project. It really did seem at that point that this was what space was about. Space was for space exploration, just as ships were for exploring the Earth. And then you think about that last statement, you realize ships aren't for exploring the Earth. They happen to be used for exploring the Earth, but they were used for everyday commerce, they were used for many, many things. And so space, once we'd conquered it, and we human beings had conquered it, we had to think how we exploited it, how we used it in every possible way, but exploration was one of them. And exploration really does push the edge. The Americans achieved an extraordinary thing in getting 2 people onto the moon in 1969 in a crash program that really was stunningly impressive, stunningly funded, and it had a goal. Exploration has a goal. After they'd met the goal, of course, the question was, what do we explore next? And they've not really, to be honest, decided. And I'll come to that right at the end.